Students, once again welcome to another lesson from iCampSA. Today we're going to be doing trigonometric functions, and this is actually an introduction to trigonometric functions since it's grade 10 curriculum. Okay, let's get into them. So we've already covered a little bit about trigonometry, in terms of the trig ratios and spatial angles and so forth. And we have also covered quite a lot about functions. We have introduced the straight line functions, your parabola, your hyperbola, and the exponential functions. So also the trigonometric functions that we have introduced, they also have their own function. This is what we are going to be covering today. Those three trigonometric ratios that we have introduced, your sine, cosine, and tangent, they have their own functions, which means they can be represented graphically, and that is what we're going to be doing. So let's get into it. All right, so first thing first, we have the basic sine and cosine functions, and then the basic sine and cosine function, we have this one here that you see there. That is the basic or the simplest form of the sine function, if I may write here, just the simplest form of the sine function. What do I mean by that? I mean nothing has been done, it's just as it is when you see it in that form of y is equal to sine theta, so theta represents the angle and the y is the corresponding coordinate or corresponding points for each of the angles we're gonna be covering. So as you know, with functions, they can be shifted up or down, they can be shifted horizontally, and they can also be stretched. The same thing applies to the trigonometric functions. They can also be shifted up and down, they can be stretched, and once we deal with stretching and shifting the function and also reflecting the function, that is when we deal with the general formula that you see here. The general formula for the sine function is y is equal to a sine theta plus q. As you might know, or you might be already familiar if you have watched our course on function, is that once you introduce that a does two things, and those are what the a defines the vertical stretch. It defines the vertical stretch, so it stretches the function further away from the x-axis or from the baseline, and it also, for the trigonometric function, it determines the amplitude of the function, the amplitude of the function, so basically the amplitude is also it tells us, how far is the function stretched from the baseline, so generally from zero, from 0. Okay, and then a negative sign of a means the function has been reflected about the x-axis, so the function has been flipped, so if originally you had a function that goes like this, once you have the negative a, or the negative a introduced, then you'll see that the function would be flipped, and it would be something like that, so as we might be familiar with it, a negative sign of a means the function has been reflected about the x-axis. Okay, and then next we have the variable q there. Q for the trigonometric function, it still defines the vertical shift, so it defines the vertical shift of the function, and the vertical shift, is the up or down shift. Just gonna say up or down. It defines the vertical shift of the function, so when you see say maybe you're given a formula or an equation of y is equal to 2 sine theta minus 1, that that minus 1 represents that the function has been now shifted 1 unit downwards, so that's what's represented by the variable q. Okay, so for you guys to actually get to understand what we are dealing with, let's go ahead and sketch this sine function, and see how it comes out, and then we would further look into more characteristics of this function. But basically, this formula, the general formula that you see here, it embodies everything that you're gonna be covering regarding the trigonometric function, or for the sine in this case. Okay, so in order to sketch our function, what do we have to do? Let's start by actually filling the table. So we have those values of theta, those degrees, so we're just gonna go into your calculator and substitute those values of theta. You substitute them and find the corresponding values of y, so you go to your calculator, you punch sine where theta is equal to 0. You will see, and make sure that when you are calculating the corresponding y values, you always set your calculator to degrees, or that small d that you see there. So you always set it to degrees. So where theta is 0, y is also 0. And then at 90 degrees, y is 1. At 180 degrees, it's what is 0 again. And then at 270 is -1. At 360 it is 0. So those are the values. You can use any other intervals, like 0, 30 degrees, 60 degrees, and so forth, if you wanna have more values, but for the sake of space, we're just gonna use the intervals of 90 degrees. Let's go ahead and now calibrate our what you call this thing, our axis. So this is y axis. Okay, so this is gonna be our 1. We have 0 here, and then we have -1, and then let's go, we're gonna have 90, 180, 270, 360. So we're gonna have 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, this is your theta axis. Okay, so any variable can be actually used for the theta axis. They can give you sine x. Just know that sine x, that x stands for the degrees. Okay, so let's plot our points where theta is 0, y is also 0, where theta is 90 degrees, y is 1, where theta is 180, y is 0, when theta is 270, y is -1, and when theta is 360, y is 0. Okay, and then what you do next, you have to draw a smooth curve. Across your dots. So you're gonna have a smooth curve. Yeah, like that. Okay, and this is how your sine function looks. It goes from 0 to 1 to 0 again to -1, and goes back to 0. It goes back to 0. So with a trigonometric function, once we reach that 360 degrees there, what you would see happening, if we were to plot our function, beyond 360. In fact, I think we're going to do that. You will see that the function will start repeating the same shape again. So and that tells us that it takes 360 degrees for this function to actually be repeated, or to start repeating itself. So we say from 0 to 360 degrees, the function has completed a cycle, and that cycle is called what? A period. You will see once we get into the characteristics of the trigonometric function. So I just wanted to touch on that. Yes, okay, let's come here. Okay, let's come here. So we have the characteristics of the sine function. Characteristics of the sine function. We start with the minimum value. So we know that the minimum value, nothing has changed, it's still the lowest value on the graph. So we say it's the lowest value, it's the lowest value on the graph. It is the lowest value on the graph, and that is the minimum value on our function. And then let's come here to our function and see what is going to be our lowest value. Our lowest value on the graph is going to be -1. So we're going to say min is equal to -1 for this sine function that we have there, the simplest sine function or the most basic sine function. And then next, what do we have? We have the maximum value. As the name suggests, the maximum value is the highest value on the graph. Okay, and then let's come to our function here. The highest value is going to be what? It's going to be +1. It's going to be +1. So say max is equal to 1. Max is equal to 1. And then next, we look at the range. A range you are familiar, you guys you are familiar with. I would like to hope so. It's basically the y values for which our function exists. What is going to be our range here? Let's come to the function. We can see that the function range is between 1 goes down to -1. Anything beyond 1 and anything beyond -1, our function doesn't exist. So our range is between what? Is between 1 and -1. So we say for our range, y is the element of from -1 to +1. That is our range. Okay, and then next we have an amplitude. The amplitude, I said, is the distance or is how far the function is actually stretched from the baseline. Is how far this function is stretched from the baseline. And then we have a formula that we actually use to determine the amplitude, even though we can actually read it from the what you call this thing, from the equation. You will see, since it's given by a, but it's always going to be positive. Okay, so the amplitude, I'm saying it defines how far is the function stretched how far is the function stretched from the baseline, So let's come to our function here. At 0, this is where we have the baseline. This is where we have the baseline. But to make your lives easier, you're just gonna use this formula to determine the amplitude. So defined formula for amplitude, just gonna say amplitude is equal to, just gonna say 1/2 and then open bracket max value, say max value minus min value. So if you use this formula, you will get your amplitude. So let's calculate the amplitude for this function. The max value is what is, so for our function here, our a is gonna be 1/2 into what is the max value. The max value is 1 minus, what's the mean value? Mean value is -1. 1 minus 1, therefore it's gonna be 1 plus 1 is 2 divided by 2. The amplitude is gonna be 1. So for this particular function that we have here, I'm saying the amplitude is how far the function is stretched from the baseline. See this line that I'm drawing here will give us our amplitude. It will give us our amplitude. So this here will be your baseline. So you can read it from the graph directly, but always remember that the amplitude is always positive. Okay, let me in fact put that in writing. Always amplitude is always positive, because I know some of you, once you start dealing with flipped or reflected function, and you see the function starts by going below the x-axis, and then you think now your amplitude is -1. Now we take the positive value. If your amplitude is -1, so you're gonna just take the absolute one. So your amplitude is gonna be a +1. And then we have a period next. I've already touched a little bit on the period. I said the period is how long it takes for the function to repeat itself, or to complete each cycle. So it defines, let me just say how long it takes for the function to complete one cycle. How long it takes for the function to complete one cycle, that is our period. Okay, and then the period is in degrees, it is given in degrees. So for this function that we have here, as I've already told you, that as we go from 0 up to 360 degrees, you see the function will go above and then go below and ultimately comes back to 0. Once you are here, the function has actually gone 360 degrees. That's a full revolution, or that's just one complete period. So it takes 360 degrees for the sine function to complete one cycle. So just gonna say the period for this function, the period for this function is equal to 360 degrees. The period is equal to 360 degrees. So with the functions you are dealing with in grade 10, what you need to know, the about 95% of the time your function won't be stretched horizontally. It won't be stretched horizontally, because stretching the function horizontally also changes its period. So 90% of the time the period for the sine function and the cosine function will be 360 degrees. If you are asked in an exam what is the period of this function, it's a sine function or a cosine function, just go with 360 degrees. If you maybe forget to how is the period calculated or determined. Okay, so before we move to the cosine function, I want to demonstrate something for you guys about the period. As I've already mentioned, that the period is how long it takes for the function to repeat itself. Let's come here. What do I need? Okay, I'm just gonna need this, copy. Just wanna show you something about the period. Let's put it here for now. Okay, so okay, okay, shift this one a little bit up, to here. yeah, and then this one here. So I want to increase the number of degrees we're gonna be looking at. So we'll go from 360 degrees. What's this? 360 plus 90. 360 plus 90, I think it's gonna be 450. So we go from there to, let me see something. Okay, seems as if I can't squeeze this. Okay, and then let me add the page. In fact, let me add the page. So the period is how long the function it takes for the function to complete one cycle. I should have done this from there. Where to go? Okay. Oh, where did I add the period now? The page. It should come here. Yeah, this is where we are. This is where we are. I'll start this one afresh. Okay, so I want to show you something about the period, because after completing one cycle, what happens with the trigonometric function is that they start repeating the same shape again, and that is what I actually want to demonstrate for you guys. That is what I want to demonstrate for you guys, and I'll need a second table here, and then we're gonna increase the number of degrees we are looking at. Oh, this is actually gonna be the same. Okay, and then we go from 360 to 450 degrees, and then we add 90, we go to 540 degrees, and then we go to 630 degrees plus 90, we go to 720 degrees. Yeah, I think that should be enough. We can include 810 degrees. Okay, and then let's come here, say sine of 450 degrees, which is the same as, it's gonna be 1. Sine of 450 is gonna be 1, and then sine 540 it's gonna be 0. Sine 680 is gonna be -1. Sine 720 is gonna be 0. Yeah, let's end here for now. Okay, so we're gonna sketch once again, but now we're gonna be sketching a little bit longer function. With more degrees. Okay, let's use this as our 1. This is our -1. This is 0. We have 0 here. We have 1, and then we have -1 here. Okay, and then let's calibrate the data axis. We're gonna have 90, 180, 270, 360, 450, 540, 630, 720. Okay, so I'm saying this is gonna be 90, 180, 270, 360 degrees, it's 450 degrees, 540, 630, and 720 degrees. Okay, let's plot our point. We're gonna have 0 and 0. We have 90 and 1. We have 180 and 0. We have 270 and -1. Then we have 360 and 0. That is for the first round. Okay, stretch it a little bit, and then like that. And then from there we have what, 450 and 1, 450 and 1, we have 540 and 0, we have 680 and -1, we have 720 and 0. Let me use a different color here. We join our curves like that. Yes, so you see what happens here. Once we reach that 360 degrees, from here, from 0 to 360 degrees, we have this function that you see here, and then from 360 to 720 degrees, of which is another 360 degrees, because if you say 720 degrees minus 360, that is 360 degrees. So for every 360 degrees, this function repeats itself. For every 360 degrees, the function repeats itself. For every 360 degrees, the sine function repeats, or let's say the sine function completes a cycle, and that is your period. Hopefully that helped in clarifying what is a period. This is our data axis. Okay, so the period of the sine function is 360 degrees. Okay, let's go ahead and do the cosine function. The most simplest form of the cosine function is what? Is y is equal to cos theta without shifting or doing anything. This is the simplest form. This is the simplest form of the cosine function, simplest form. And then next we have the general formula for the cosine function, of which is y is equal to a cos theta plus q. We have those variables a, cos theta, and q. What do they mean? A defines the vertical stretch. It defines the vertical stretch, of which is what? Is the amplitude of the function. It defines the vertical stretch, of which is the amplitude of the function. Okay, and also the negative sign. If a is negative, that means the function has been reflected about the x-axis. We're going to do an example to show what we mean by that. Okay, and then q defines the vertical shift of the function. So nothing has changed. We still it's basically the same thing. We have done, or we have talked about on the functions and also on the sine function that we have just did right now. So q defines the vertical shift of the function. Okay, and then let's go ahead and sketch the cosine function and see how it looks. Okay, so first thing first, we need to find the corresponding y values. Fill in the table, and then we can sketch our function. So you just go to calculator, you say cos 0, and you get 1. Cos 0 is 1, and then you go to cos 90, which is 0. You go to cos 180, of which gives you -1, and then you go to cos 270, of which is 0, and then you have cos of 360 degrees, gives you 1. It gives you 1. Okay, let's calibrate our Cartesian plane, or axis. So we're gonna have 90, 180, 270, 360. Okay, here we have 1, -1, we have 0 here, 90 degrees, 180 degrees, 270 degrees, 360 degrees. These are your theta axis and these are your y axis. Let's plot our function. Where theta is 0, what is our y, corresponding y coordinates is gonna be 1. So we're gonna have a point there. And then when theta is 90 degrees, y is 0. When theta is 180, y is -1. When theta is 270, y is 0. When theta is 360, y is 1. Okay, then once we are here, we can actually join our points to form a smooth curve. Okay, yeah, I think that one is a little bit better. Okay, so those are the points that we have there. And this is how the cosine function looks. We can already pick up a few things: your minimum value there, your maximum value, which is 1. And then and look, the same thing happens. You go from 0 to 360. Once you reach 360, if you were to do the same thing and look for and plot this function for even bigger or for more number of degrees, what you will see happening is that the same shape will start happening again, or will start occurring again. So once again, the period for this cosine function is 360 degrees. Okay, so let's go ahead and look at the characteristics of the cosine function. Okay, so first thing first, we have the minimum value. We have already explained what is the minimum value, and that is the lowest value. It's the lowest value. It is the lowest value on our graph. And once again, our minimum value here is what? Is -1. So we're just gonna say min value is equal to -1. Maximum value, the highest value or biggest value in our function, once again is still what? Is still 1. Okay, and then next we have the range. The y values for each our function exist. It goes once again from -1 to 1. It ranges between those 2 points. So for the range, say y is the element of -1 to 1. Okay, and then the amplitude to say it's how far the function is stretched from the baseline. This is our baseline, and you can see that the function is stretched from 0 to 1, so you can either use the formula that I've introduced for you, or you can just determine the function the amplitude by looking at the function. Once again, the amplitude of this one is a is equal to 1. That is the amplitude. And then the period, once again, is gonna be p is equal to 360 degrees. So the cosine and the sine function are very similar. The cosine and the sine function are very similar. As you can see, they have the same period, so they generally take the same amount of time to repeat, which is 360 degrees. In fact, for the functions you are dealing with in grade 10, I think the period about 95% of the time it's just gonna be 360 degrees for the cosine and the sine function. And then, as you will see, as we get to the tangent function, then the period now changes. It becomes 180 degrees. But yes, hopefully you guys do understand that. Let's go ahead and do some examples. So here we have example number 1. And then for example number 1, it is visible. We are given y is equal to 4 sine x and y is equal to negative 3 sine x. And then we're asked to sketch the graphs on the same set of axes. For x is the element from 0 degrees to 360 degrees, so that is our domain, if you may say. And question number B, you are asked to write down the minimum, maximum, the range, the amplitude, and the period of these functions. Okay, I want you to pay attention to a few things. You see that the value of a has changed now. It's 4 for this one, and it's positive, so it's not flipped. And then we have the value of a is negative 3 there. Is negative 3, of which means our function has been flipped. It has been flipped. Okay. So first thing first, let's complete our table for this function. Let me see if I can just get this one here. Copy. Let's complete the table for these two functions. Okay, and then let me paste again and see. Okay. Oh, okay. No, it's bad. Okay, oops. Okay, so that is our table. The functions we are sketching is what? Y is equal to sine x. Y is equal to 4 sine x. It's 4 sine x, and then the other one is y is equal to negative 3 sine x. Y is equal to negative 3 sine x. Okay, let's go ahead and find the corresponding values. For 4 sine 0, we're gonna have 0. For sine 90, we have 4. 4 sine 180, you have 0. For sine 270, we have negative 4. And then for sine 360, we have 0. Okay, and then let's do for negative 3 sine 0, of which gives us 0. Negative 3 sine 90 gives us negative 3, and then negative 3 sine 180 gives us 0. Negative 3 sine 270 gives us 3, and then negative 3 sine 360 gives us 0. Okay, we have the table now, so we can go ahead and sketch our function. We're gonna need the Cartesian plan. I'll just take this one, copy. We're gonna need the Cartesian plan, paste. Let's come here, and let's, since we do have space, let's give ourselves a little bit of space. Okay, extend those. Okay, and then we gonna have, say, 1 2 3 4. 1 2 3 4. It's negative 1, negative 2, negative 3, negative 4. We have 1 2 3 4. Then we have 0 90, 180, 270, 360. Okay, let me actually stretch that one a bit. We have 90, 180, 270, and 360. and plus 60 degrees. Okay, let's start with the first function of y is equal to 4 sine x. Y is equal to 4 sine x. We'll use the trim pen. So where theta is 0, so we're essentially dealing with theta. Forgot to check. We're essentially dealing with x here. Okay, this is our y, our x. So the angles can be represented by any variable, so it's not just only gonna be theta. Just like here we are using x. Okay, so where x is 0 degrees, y is also 0. Where x is 90 degrees, y is 4. It's gonna be there. Where x is 180, y is 0. Where x is 270, y is -4. And where x is 360, y is 0. Okay, then once we have our points, we join them with the smooth curve. Like that. Okay, that's our first function. Let's label it. This is the one for y is equal to 4 sine x. Y is equal to 4 sine x. And then next, let's sketch the other function of y is equal to -3 sine x. Y is equal to -3 sine x. We're gonna use a blue pen. Where x is 0, y is 0. Where x is 90 degrees, y is -3. Where x is 180, y is 0. Where x is 270, y is 3. Where x is 360, y is 0. Okay, and then we join our points. Yes, like that. And this one that we have here is the one for y is equal to -3 sine x. -3 sine x. It's -3 sine x. And as you can see here, that this function of y is equal to 4 sine x, it is further away. In fact, let me use it as a point. It is much further away from the x-axis, because of what? Because of the amplitude, that 4 there. Remember that the value of a introduces the vertical stretch, so it stretches the function further away from the x-axis. So if it becomes bigger and bigger, the function would be stretched much more away from the x-axis. Hence why our a here is equal to what? Is equal to 4. And then for the other function where a is equal to -3, the stretch, that's the stretch, not the amplitude. The amplitude is still just gonna be a +3. Our a is equal to +3. This one is it's for the amplitude. It's how far the function is stretched from the x-axis. Okay, so we have the function have been sketched. Okay, have been sketched. Let me include the dotted lines. So you see that the one with a smaller amplitude is closer to the x-axis than the one with the bigger amplitude. And then for each function, write down the minimum, maximum, the range, the amplitude, and the period for each function. Okay, so let's come here for the trim function of y is equal to, or just use the trim color, the minimum value. What is the lowest value for the function of y is equal to 4 sine x is what? Here, this is where we have the lowest value, of which is -4. The lowest value, the minimum value, is equal to -4. The maximum value of the function, the maximum value is what? Is +4. And then What else are we asked? Is the range. For the train function. You can see that our function goes from 4, between 4, it ranges between 4, the value of 4, and what, and the value of what, of -4. So our range is from -4 to 4, so our function would keep on repeating back and forth between those two values. So the range saying y is the element of -4 to 4, -4 to 4. And then next, what do we have next? Let's see, is the amplitude. So the amplitude, we have already determined that the amplitude is what, is 4, but let's use the formula that I gave you for the amplitude. Let's use the formula that I gave you and see if we get the same answer. So I'm saying the amplitude is equal to 1/2 maximum value minus minimum value. Therefore we're gonna have 1/2 into what is maximum value. The maximum value is 4 minus the minimum value, which is -4. Therefore we're gonna have, what is 4 minus 4 minus 4? Sorry, it is 4 minus -4. Therefore it's 4 plus 4, which is 8/2. Therefore the amplitude is 4. The amplitude is 4. And then next, what are we asked to? We were asked the period. So the period, how long it takes for the function to repeat itself, it is 360 degrees. Let me add the page. Done. Okay, so next we are asked about the period. The period is what, is 360 degrees. Okay, and that is the train function. Next, let's deal with the function of y is equal to -3 sine x. Y is equal to -3 sine x. Okay, first thing first, we are asked about the minimum value. The minimum value of the function. What is the minimum value of the function? Here we have the minimum value, of which is what, is the lowest value of the function is -3. And then next we are asked about the maximum value of the function. Maximum value, here we have the maximum value of which is what, is 3. That's the maximum value, which is 3. And then next is the range of the function. So once you have the minimum and the maximum value of the function, those, they also tell you the range of the function, because if remember that after the maximum value, there is no other value that exists for the function. There is no value bigger than the maximum value. There is no value on our function that is less than the minimum value. So that also gives us the range of the function. So for the range, y is the element of from -3 to +3. From -3 to +3. Okay, and then next is the amplitude. The amplitude, I said, we can read it from the function here, but it's always positive. So the amplitude is what, is 3, just a +3. But let's use the formula, so the formula will actually always give you a positive amplitude. The formula is equal to 1/2 into max value minus minimum value. So the amplitude is 1/2. What is the maximum value? The maximum value is 3 minus 3. Therefore we're gonna have 1/2 into, what is 3 plus 3 is 6. 6 divided by 2 is gonna be 3, a +3. Okay, and then next we are asked about the period. 90% of the time the period of the sine function in rate 10 is gonna be 360 degrees. But you can also see from the graph that the function, it takes 360 degrees to complete one cycle. So this is our period, 360 degrees, 360 degrees. So that is that for example number 1. Let's go ahead and do example number 2. Okay, so for example number 2 is for cosine function. Cosine function, it reads as follow: given y is equal to 3 cos x, y is equal to 3 cos x, we already know that the amplitude is going to be what? It's going to be 3. And y is equal to minus 2 cos x, amplitude is what? It's positive 2. Okay, sketch the graphs on the same set of axes for theta. Why we use theta here? Let's use x, it's much more easier. For x is the element from 0 to 360 degrees. Write down the minimum value, maximum value, the range, the period, and the amplitude. Okay, we're gonna need the table. Copy. I come back for the Cartesian plane. Let's put our table. Okay. This is our table. Okay, what are the functions we're looking at? Is y is equal to 3 cos x, y is equal to 3 cos x, and y is equal to minus 2 cos x. Y is equal to minus 2 cos x. Okay, let's find the corresponding values. So 3 cos 0, where x is 0, we have 3, where x is 90, we have 0, where x is 180, we have negative 3, where x is 270, where x is 270, we have 0, where x is 360, we have 3. Okay, and then next let's do the other one with negative 2 now. Negative 2, where x is 0, y is negative 2. At 90 we have 0 to 180 degrees, we have 2, positive 2. At 270 we have 0. At 360 is minus 2. Okay, so about the function of negative 2, since the value of a, the coefficient of cos x, is negative, that means the function has been reflected about the x-axis, of which is the same thing as we saw with the blue function here. So normally the sine function, it always starts from 0 and goes upward. Once it starts from 0 and goes below the 0, that means it has been reflected, as you can see there. So the same thing as we know with the cosine function, that the cos function start from positive and goes below 0, or it goes to negative values, if I may say. And once it has been reflected, we'll see it will start from the negative, goes above, comes back below. That's when it has been reflected. But let's go ahead and all right, we have completed the table. Let's sketch now our function. Copy. Let me see. In fact, I should have just copied everything. Let's sketch our function. Let's sketch our functions. Okay. Let's start with the one of 3 cos x. 3 cos x, where x is 0, cos is 3, where x is 90, y is equal to 90, 0 degrees. Sorry, 0. It's just 0. Where x is 180 degrees, y is -3, where x is 270, 0, 360, and 3. And then we join our points. Let me start with this one actually. We join our function. Yes. Okay. And then this one is for y is equal to 3 cos x. And then let's do the other one of y is equal to -2 cos x. The second function is the one we are plotting now. At 0 degrees we have -2. We have -2. At 90 degrees we have 0. At 180 we have +2. At 270 we have 0. At 360 we have -2. We join our points. Okay, and this function is the one for y is equal to -2 cos x. Y is equal to -2 cos x. Okay, and then same thing again, we look for the minimum value, maximum value, the range, the period, and the amplitude. Okay, so let's start with the red function. Let me see. Let me actually move this a little bit higher to there. Okay. The minimum value. What is the lowest value on the function? Here is -3, equal to -3, and then the maximum value, highest value is what? As you can see here, is +3. Next we look for the range. I said the range, the minimum and the maximum value also gives you the range, so the range is what? Y is the element of -3 to +3. That's our range. And then the amplitude, the period, we'll ask the period first here. The period is what? We're dealing with a cosine function. The period is 360 degrees. And then the amplitude, whereas the amplitude, how far the function is stretched from the baseline, is gonna be what? It's gonna be 3. You can use this is our amplitude here. This is our baseline, and then the function is stretched 3 units from amplitude is actually, it's actually 3 units. The amplitude is 3 units, from the baseline. You can use the equation that I gave you of 1/2 open bracket maximum value minus minimum value. You still should get 3. Let's go ahead and do for the other function. I'll just shift this one a bit here. For the paper one of y is equal to -2 cos x, what is the minimum value? Minimum value of the function, the lowest value, come here, is what? It's -2. The minimum value is -2. The maximum value, highest value on the function, there we have it, is what? Is +2. And then we look for the range. if the maximum value is 2, the minimum value is -2, that means our function ranges between those 2 points. Therefore, y is the element from -2 to +2. And then the period, how long it takes for our function to complete one cycle, it's 360 degrees. And then we have the amplitude. The amplitude is the coefficient that you see there, but it's always positive. Go with the positive, just don't mess that up. So the amplitude is gonna be what? Is gonna be 2, the positive 2. That is your amplitude, and that is how you will answer these questions. Okay, and then next we have example number 3. Okay, so we're given y is equal to 2 sine x. What is that? 2. It gives us the amplitude, it's the vertical stretch, plus 3. So what has happened now? The function has been shifted what? 3 units upwards, so you will see. And then next we have y is equal to -3. Amplitude is 3, and that negative, it means the function has been reflected about the x-axis, -2, and also it has been shifted 2 units downward, so let's go ahead then and sketch the graphs. So for A, sketch the graphs on the same set of axes. For x is the element of, okay, now we go from 0 degrees to 270 degrees. Okay, that is our domain. We are restricted from 0 to 270 degrees. Okay, what do we need? Let's do our table, but now we're only gonna go up until 270 degrees. In fact, let me see something. I think we can I was thinking of using a different interval, maybe the intervals of 45, just to give ourselves more points. 0, 45, 90, 135, 180, 225, 270. Okay, yeah, let's use those intervals. Okay, let's use those intervals. Hopefully they will fit here. Okay, so we're gonna 0 degrees, 45 degrees, just for a change, 45 degrees, 90 degrees, 135 degrees, and then we have 180 degrees, 225 degrees, and then we have 270 degrees. Yeah, that's the last one. Let me see, I didn't miss anything. Hopefully not. Let's find the corresponding values. Go to your calculator. We're dealing with what now? Oh, it's actually, this one is also changed. So let me do it like this. Give ourselves a little bit of space. Okay, so the first function is y is equal to 2 sine x plus 3. Y is equal to 2 sine x plus 3. And then the second one is y is equal to -3 cos x minus 2. Y is equal to -3 cos x minus 2 Let's find corresponding values. Is 2 sine 0 plus 3. 2 sine 0 plus 3, we have 3. And then let's go to 45. 45 is 4.4. I'll go with 4.4. And then let's go to 90. It's 5. 135. At 135 we have 4.4. 180 we have 3. At 225 we have 1.5. At 270 is 1. 270 is 1. 270 is 1. What we'll say with this function, it actually doesn't complete one full cycle, so yeah. Negative 3. Okay, let's do the other one. It's negative 3 cos of 0 minus 2. That gives us a minus 5. And then negative 3 cos 45 minus 2, it gives us a minus 4.1. Negative 4.1. And then at 90, corresponding value is negative 2. At 135 we have 0.12. 0.12. At 180 we have 1. At 225 we have 0.12. At 270 we have negative 2. Negative 7. Okay, now that we have those, we can go ahead and sketch. Sketch. Let's plot our points. Let's get the Cartesian plane. Let's get the Cartesian plane. Copy. We are here now. Paste. Let's start everything afresh. Okay, let's bring it a little bit lower. Okay, I want to stretch it again. Okay, and then let's calibrate it. We're gonna have 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. Then we're gonna have 1, 2, 3, 4, 5, 6. And then next we're gonna have 0, 45, 90, 135, 180, 225, 270. We have 45 degrees, 90 degrees, we have 135 degrees, we have 180, we have 225 degrees, we have 270. Did I miss something? I hope not. 270. Okay, this is our 0. Then 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, let's start by plotting the points for the y is equal to 2 sine x plus 3 function, where x is 0, y is 3. Y is 3. And then where x is 45, y is 4.4. So almost 4.5. So somewhere there. And then where x is 90, y is 5, 135 and 4.4, 180 and 3, and then 225 and 1.5. So 1.5 will be around there, and then 270 and 1, 270 and 1, yes, 270 and 1, 1.5. Oh, what am I doing? That is 2. It's gonna be here, yes. And then you join your function. Didn't come out smooth. Okay, yes, let's see. Okay, not bad. Okay, and that is our function, and remember that the function ends there at 270. Okay, let's sketch the other one. Let's actually read the other function, where x is 0, y is -5 here, where x is 45, we have -4.1, so it's just below 4. At 90 we have 2, at 90 we have -2, so it's gonna be there. 180 is 0.12, a positive 0.12. That's 135, by the way. At 180 we have 1, and then 225 we have 0.12 there, and then 270 we have -2 again. And then from there we do what we do best, and that is to join the points. We join the points. Okay, and then next we are asked to determine the minimum value, maximum value, the range, the amplitude, and the period. Okay, let me see. Let's just come here for the people function. Let me do it like this. Y is equal to 2 sine x plus 3. Let me see, maybe it can fit here. Minimum value. What's the lowest value on this function? Come here to our function. See there at 1. That is our minimum value. That is the minimum value. And then we have y. Okay, and then next we'll look for maximum value. The maximum value is here at what? At 5. That is our maximum value. Next we are asked to write down the range of the function. I said the minimum and the maximum value also gives you what? It gives you the range, so that our function goes between 1 and 5. So our range is gonna be y is the element of from 1 to 5, and then next the amplitude the amplitude of the function, you can use the formula. It's going to be 1 over 2 into 5 minus 1, which is 4 divided by 2 is 2, but you can also just come here. That gives you your amplitude, and that amplitude is what? Amplitude, the amplitude is equal to 2 units. And then next is the period. So even though the range you are dealing with, the domain that they gave you here is from 0 to 270 degrees, you come here to your function, you see that the function is not complete, so it hasn't completed a full cycle, therefore our period remains. Our period is still what? The period is 360 degrees, so it hasn't changed. It's just a way of trying to trick you, so don't make a mistake with such. Okay, let's come to the red function of y is equal to the cosine function. Y is equal to -3 cos x minus 2. What is the minimum value, lowest value, or the smallest value of the function is -5. We see it here is -5, and then we have the maximum value. The maximum value is gonna be what? Here, that is the highest point there. It's gonna be 1. That's the maximum value. The range is also given by the minimum and the maximum value. We say y is the element from, always start with the smaller value, which is -5 to 1. Okay, and then the amplitude is what is given there. It's gonna be a +3. That is your amplitude. It's gonna be a +3. Amplitude is equal to 3 units. Is equal to 3 units. And then lastly, the period. Once again, this function is incomplete here at 370. If we had more degrees, maybe it will end up coming back to what? To -5, but that still doesn't change that the period of this function is what? Is 360 degrees. 360 degrees. Just because they limited the domain to 270 degrees doesn't mean that now the period has changed. The period is still what? Is still 360 degrees. Okay, let's see. Okay, and then we will have tangent function. Okay, so for now, this will mark the end of today's lesson. I hope you guys learned something in terms of the trigonometric functions, and then next we're gonna be doing a lesson on the tangent function, and then more questions, more examples regarding the trigonometric function. This was just an introduction to the trigonometric functions, and until we meet again, I wish you guys good luck and good studying.